We're going to continue with a little bit more work in section 6.1. We're going to finish factoring out the GCF and also do a little bit of work called factor by grouping. Now, as far as the GCF is concerned, a little reminder here. A lot of times, if there's a factor in common to a group of terms in a polynomial, we'll pull that factor out. And in this case, that factor was a y squared. So if I factor out the y squared, what gets left behind? Well, an x cubed minus 2x squared plus 3x and a minus 6. So that the y squared was in common to all of these. There's still some more factorization we're going to do, but I'm not going to do that quite yet. So leave a little space in your notes here. We'll fill in. Give yourself about an inch and a half or two. We'll come back and fill that in. But right now, it's just a reminder about factoring out the GCF. And we're going to see that factor out the GCF in a different way. Something that you might not initially think of as being a greatest common factor. And that's problem number 74. R times t plus v plus 3 times t plus v. Okay. So let's see here. Is there anything common to both of these terms? Yeah, t plus v. So t plus v is common to both of those terms. I'm going to factor that out as my GCF. T plus v. Now what's that leave behind? Well, it leaves behind an r and a 3. So it's going to be t plus v times r plus 3. And yay, you've completely factored it. Now what's different about this is that our GCF is a whole binomial term. Up till now we've had monomial type terms when we factor something out as a GCF. But there's nothing wrong with factoring out bigger terms like that. So where is this heading? This is kind of like the beginning step of something called factor by grouping. And that's what we're going to discuss next. Factor by grouping. This is something that you're going to try when you have 4 terms to factor. So that would be, or an example of that would be problem number 78. Bx plus bz plus 5x plus 5z. Now the first thing you should always do when you're trying to factor something is look for and factor out any GCF. Is there a GCF here? Is there a greatest common factor that's common to all 4 of these terms? The answer is no. So what we're going to do is we're going to set our sights a little lower. Let's look at the first 2 terms. Is there anything in common to both of those? A b. So we'll factor out the b. If I factor out the b, what's left behind? X plus z. Good. Let's look at the next 2 terms. Is there anything in common to both of those? A 5. So it'll be a factor out of plus 5. And again, it leaves behind x plus z. Okay. Notice that x plus z is itself now a common factor. So I can factor that out too. If I factor out the x plus z, that again leaves something behind. What gets left behind? Good. B plus 5. B plus 5. So trying to keep things all color coordinated here for you can see where they come from. B plus 5. And that's it. Great. how could we check it? If we wanted to check it, if we're looking at that going, you know, that looked like hocus pocus, I'm not so sure about that. How could you check it? Yeah, FOIL it out, right? Just multiply these two together. You get x times b, which we'd probably write as b times x, plus x times 5, there's your 5x, b times z, and then 5 times z. So it checks. You can check all your answers in this section by multiplying them back together. Nice. Let's do problem number 86. We'll actually do this one in two different ways. xy plus 3y squared plus x plus 3y. Well, there's nothing in common to all four of these terms, so that's a bummer. Let's keep going then. Let's set our sights a little lower. Let's see if we can factor out something from the first two terms. What can I factor out there? Yeah, factor out a y. So let's take out the y. So a y times x plus 3y. Is there anything I can factor out of the second pair? Not really. And if there's nothing to factor out, let me make a suggestion. Let's factor out a plus 1. Now factoring out a 1 is not going to change anything. If you distribute that 1, you're just going to get x plus 3y again. But that 1 is a good placeholder because these two terms are your common factor, and I have to factor that out. So when I factor that out, what gets left behind? Y plus 1. Y plus 1. So here's your y right here, and then here's your 1. So right here. Nice. So that's where that's all coming from. A lot of times people don't factor out that 1, and that's okay. But if they don't factor out that 1, there's a tendency sometimes to just leave a y here. Now, if you had just a y, then there would be something that would be clearly wrong. You're supposed to be able to check these things by multiplying them back in. If I distribute the y, I get xy plus 3y squared. I get these two terms, but there's nothing to give me these two terms. You need that plus 1 there as a placeholder. I suggest that when you factor these things, you take it out right away. Just write it there. So that's one thing that I want you to get from this example. Are we okay with that much so far? McKenna, looking all right there? All right. Now, let me introduce you a little bit of a mathematical notation. So, in an English class, this would be 4. But in a math class, it's called 4 factorial. I like doing that. It always wakes people up. It stands for 4 times 3 times 2 times 1. It's the number of ways you could arrange a group of 4 objects. So, for instance, this row has 4 students in it. I have 4 choices for whoever sits in the first seat, times 3 for the next seat, times 2 times 1. There's a total of 24 different ways that you can arrange 4 objects. So there's 24 different ways that I can arrange those 4 terms. Now sometimes something might not factor by grouping one way. So you could arrange it in different ways. Now what catches my eye is that both of these terms have a 3. So let's put those together. They look like they go together. They belong together. So I'll do a 3y squared plus a 3y. And then I've got these two terms kind of left over, an xy plus an x. Should I get a different factorization when I do it this way? No? All right. But the point of this is to show that you can sometimes attack this in a different way, and sometimes you actually need to. So being consistent with what we've done before, I'm going to factor out the GCF from the first term and from the second term. Judy, is there anything in common to the first two? Anything else? All right, so a 3 and a y. That's all right. That's going to leave behind a y plus 1. Good. Elizabeth, how about the next term? Is there anything in common to these two? All right, so I'll factor out an x, and that leaves behind y plus 1. And isn't that special? These two terms match. So I'll factor that out. If I factor out that GCF of y plus 1, what gets left behind? Good. 3y plus x. And the x is coming from right here. Okay. Do the colors help you follow the action a little bit better? Okay, good. So you get the same factorization either way though, right? I mean, the only difference was the order of these two binomials, but the order doesn't matter when you're multiplying. 7 times 8 is the same thing as 8 times 7. It's commutative. So if you need to, the second lesson to learn from this is to reorder things. Let's go back and attack the one that we started out with at the start of this section. Inside the brackets here, I'm going to continue doing some work. So let's look at the first pair of terms. Can I do anything to factor what's there, those first two terms? Good. Factor out an x squared. So x squared times x minus 2. And then those two terms, what can I pull out of there? A 3, so plus a 3. And again, x minus 2. These two terms match. So I'm going to keep this bracket here because I need my GCF. This should be a y squared. I need my GCF outside of the bracket. Inside the bracket, I have a x minus 2. Bless you. What else do I have inside the bracket? X squared plus 3. So an x squared and then a plus 3. So x squared plus 3. You don't need that extra set of brackets anymore. That was just keeping things straight when I had the y squared outside of all this. You could write this equally as well as y squared times x minus 2 times x squared plus 3, or you could leave the brackets. Doesn't matter to me. Either one of these is fine as the solution. We're okay with problem number 98 here. Now we've got it completed. We're going to do a couple more here in terms of factoring by grouping. I'll do problem number 110, and then maybe we'll do problem number 100 after that. Last chance for any more follow-up on problem number 98. Okay. So let's look at problem number 110. Can you take one and send one, just send it around? Thanks. So what's coming around is a nice handout about factoring in general, different steps to factoring. So this is section 6.1. You're factoring out the GCF. We're also going to work with factor by grouping, which is also section 6.1. Now, The very, very first thing that you should always try when you're trying to factor something is to factor out the GCF. So problem number 110, 4abc plus 4ac squared minus 2bc minus 2c squared. Okay. Is there something that's in common to all of these? A c, good. Anything more? A 2. So I'm going to factor out a 2 and a c from all of these. Again, I'm going to use brackets just to help visually see what's grouped together. If I take out a 2 and a c, what's left from the first term? James? 2ab. Good, 2ab. And the next term? Derek? If I factor out a 2 and one of the c's, what's left? 2ac. Yeah, 2ac, because you've taken out one of the c's. All right, good. Let's keep going. If I factor out a 2 and a c, not much left here, right? Just a minus. So minus b. How about the last term? Rochelle, what's left there? Good, minus c. Nice. So we got rid of our GCF. That's fine. Let's now see if we can't factor by grouping. So I'll factor out what from the first pair? What can I take out here? 2a, which leaves behind b plus c. Now there is something that you could and should factor out from the second pair. Does anyone see that? Robert? Minus 1. The nice thing about factoring out a minus 1 is that it changes the signs of both of those terms. So it's going to become a b plus c. Well, that's special, because b plus c is now a greatest common factor. We can go a little bit further here. That 2c stays out in front. But now b plus c is a GCF. So Roy, what's going to be left after I factor out the b plus c? Anything else? Good. So it'll be 2a here and minus 1 from here. Thanks, sir. There and here. Now I don't need these extra brackets if I don't want to. I don't have to write them. Just do it. Keep all the visuals in line. 2c times b plus c times 2a minus 1. Looking good. How are we looking on problem number 110 there? Now it's quite easy. In fact, in my morning class I missed one, and in this afternoon class you got part of the GCF. What if you just forget about factoring out the GCF altogether? If you just, you're in a panic on a test and you overlook it. Let's see what would happen here. So let's repeat our work. 4abc plus 4ac squared minus 2bc minus 2c squared. This time I'm going to charge ahead without factoring out the GCF. Maybe I just forgot it, whatever the case is. What's in common to both of these terms that I could factor out? Good, 4ac. So I'll factor out a 4ac from those two. And I'll likewise need to factor out a 2 and a c from these two. So it'll be 4ac. If I factor out a 4ac, there's not much left, is there? Maddie, what will be left? Almost. Not quite a 1. There is something left. b plus one of the c's is left. All right, so b plus c. Good. How about the second term? What can I factor out of that? Yeah, negative 2c. So, you know what? I screwed up here. It should be negative 2c. And that's going to leave behind, yeah, another b plus c term. Okay. Almost done. Let's get rid of you because you're looking really ugly. There we go. So b plus c is now a GCF, right? So I can factor that out. So it's going to be b plus c times 4ac minus 2c. Now I haven't done anything wrong yet. There's nothing wrong. But that answer doesn't quite match the answer that we got just a minute ago. But can you see anything that might help us / save us to make these answers the same? Yes. If you look here, there's a GCF of 2 and c. Now if there's a GCF here in one of your binomials, there better be one at the start of the problem. Those two ideas would go hand in hand, so that it doesn't really matter too much where you factor out the GCF. But there is a GCF here, it's 2c, and if you look back up here, like, oh yeah, I could have started out by factoring out a 2c. That's okay. You can still recover. I'll factor out the 2c there. b plus c stays the same. This is going to become 2a minus 1. So you end up in the same place either way. Before I give you one to try, are you okay with either of those two? One way or the other, I want you to get down to this as a final answer. Now, if it's by factoring out the GCF first or last, it doesn't matter to me. I'd suggest you do it first, but it's up to you. Also up to you is problem number 100. So 3x cubed minus 6x squared plus 15x minus 30. Oops. Okay, so first thing we'll do is we'll factor out the GCF from everything. And I strongly suggest you always look for an overall GCF. That's a 3. That's going to leave behind an x cubed minus 2x squared plus 5x minus 10. And from here, we can start working on things in pairs and doing it group-wise. So starting with those two and continuing with these two, let's figure out a GCF for each pair. This is going to be 3. What's a GCF for those two? X squared, which leaves behind an x minus 2. And for the second one, 5. X minus 2. Now that x minus 2 is itself a GCF now. That's in common to both terms. So it'll be 3 times x minus 2 times x squared plus 5. Yay. And you can write it again without the extra brackets. 3 times x minus 2 times x squared plus 5. Either one at the end here is fine. Both of them are fine for me. Looks good. For homework, section 6.1. Now, if you've done some of this, then just do it all over again. I'm kidding. So try 17 through 37, 41 through 53, 57 through 61, 65 through 69, and 73 through 101.